Just to review the unit circle quickly, for everything we do second semester, you're going to need to know this circle. And as I told you guys when we were doing them, it is not that you have to memorize every single place on here and have that whole picture in your head, but you need to think about this as a piece of graph paper, and that once you understand this quadrant as far as the points goes, you have the entire circle, because this side, they're just negative, positive. Down here, they're negative, negative. And in the fourth quadrant, they're positive, negative. So once we know these three, we know them all. To get the radians, we just need to be able to count by sixes or by fours. When we count the sixes, we ignore these middle lines. Okay, the 45-degree lines aren't part of our sixes, so we get rid of these red lines in here. We start counting. That's 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. You know that 6 by 6, if I get there, I know that's pi. So I'm in the right spot. Then 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, 12, 6. And again, 12 pi 6 means that I'm all the way around, so that should be 2 pi. Now, to count our radians in pi 4s, I do the same thing, but let me use a different color here. Okay, we're going to use these middle lines, and we're going to count by fourths, and I'm going to go around, including my x and y axis, so that's 1/4, 2/4, 3/4, 4/4. Yay! 4/4 means I made it to pi, halfway around. 5/4, 6/4, 7/4, 8/4. Again, 8 pi 4 is 2 pi. I made it around. Now I know radians is hard for a lot of people, but that'll get us around for our radians. Our points are also simple, and I'll show you that on the next slide. To get the ordered pairs, I'm going to look at, again, the unit circle, but this time I'm going to look at triangles. So I'm looking at this triangle right here. It's a 45-degree angle, or pi 4s. I know these two sides are the same, so that's the square root of 2 over 2, comma square root of 2 over 2, the ones that are the same. When I look at the other triangles, I'll look at this one right here. And these are not the same, but this one is shorter, so I know that y value is 1/2. And the long one is the root 3 over 2. When I do the other one, it's the same triangle, actually, as the green triangle, but this one right here, my short side this time is 1/2, so my x value is 1/2, and my y value is square root of 3 over 2. The points on the axis are the same as they've been all through middle school or whenever we first learned to do our ordered pairs. It goes 0 left and right, and 1 up, or 1 to the right, and 0 up and down. Once I have these points, we'll see that these points are going to be the same as these points in all the other quadrants with the signs changed. Today we're going to find the angle given the sine, cosine, tangent, cotangent, secant, or cosecant, the 6 trig functions. And to do that, we still have to go back to knowing our unit circle, which is right here, or we need to make sure that we know that and that we know our ordered pairs. So we need to know that the cosine is the x value and the sine is the y value. We need to memorize that the tangent is the y over the x, and that's the tangent. Okay, to get the secant or cosecant, all we have to do is flip this x value. So to get the secant, we're going to do 1 over x, or we flip, okay, the cosine. To get the cosecant, we are going to take 1 over the y value, or we're going to flip the sine, and we get the cosecant. Okay, to get cotangent, we're going to take the x value and divide it by the y value, this direction. So that's cotangent. And again, I don't mind if you memorize it's x divided by y, or you memorize that you're taking this over this. But tangent is y over x. Cotangent is x over y. Secant is 1 over the x. Cosecant is 1 over the y. Sine is the y value. Cosine is the x value. It is imperative to do the things that we're going to do in trig this entire second semester that you have these 2 things memorized, and they'll keep coming back with each new section that we do. Let's practice finding tangent, cotangent, secant, and cosecant for all the first quadrant, because if we know first quadrant, we should be able to go all the way around the unit circle. To do that, let's pick tangent first, and we're going to make a chart. So write this in your notes. You got the first quadrant points, and then you're going to write tangent. And if you have different colored pens, you can use different colored pens, because we're going to have one answer for all 4 of these different trig functions. So tangent is this over this. Okay, the y over the x. So that's going to be 1 over 0, which is undefined, for 90 degrees or pi halves. The next one is this over this. So it's root 3 over 2 divided by 1/2, which just gives me root 3. Root 2 over 2 divided by root 2 over 2 is going to give me 1. 1/2 divided by root 3 over 2 is 1 over root 3, or root 3 over 3, when I rationalize it. And this is going to be 0 over 1, which is just 0. So those are going to be all my answers for tangent. Okay, let's look at cotangent. Same idea, only this time I'm going to go the x divided by the y. So I have 0 over 1, which is just 0. Let's see, this one is going to be 1/2 over square root of 3 over 2, which the 2's will cancel, but I'll get square root of 3 on the bottom, so I need to rationalize it. 1 over square root of 2 over square root of 2 is still 1. This one, if I took x over y, I'm going to have the square root of 3 over 2 divided by 1/2, which is just the square root of 3. And if I do 1 over 0, I'm going to get undefined. So those are all my values for cotangent. All right, let's find our values for secant. Secant is just 1 over the x value, or flipping the x value. So that means for 90 degrees, 1 over the x value is going to be undefined, 1 over 0. Okay, 1 over the x value here is flipping 1/2, so that's going to be 2. 1 over 2 over 2 is going to give me 2 over root 2. When we rationalize that, that's just square root of 2. 1 over square root of 3 over 2 flips it, and then rationalize it. I get 2 square roots of 3 over 3. 1 over 1 is just going to give me 1. So those are all my secants of theta. All right, the last thing we find is cosecant. Let's use this color. So I have cosecant, and that's going to be 1 over the y value, or flipping the y value. So again, I look at my pi halves right here, and I have 1 over the y value, which is just 1. 1 over the y value here is 2 over root 3, or 2 root 3 over 3. Okay, 1 over the square root of 2 over 2, just flip it and rationalize it, square root of 2. 1 over the y value here is 1 over 1/2, which is just 2. And 1 over 0, again, will give me undefined. So these are all the values you can get for tangent, cotangent, secant, and cosecant. And all we're doing is going around our unit circle again and have memorized which one's x, which one's y. Tangent, of course, is y over x, and cotangent is x over y, which I just like to think of as I'm going to divide those 2 ordered pairs that way, or I divide the ordered pairs this way. Okay, secant is 1 over x, or I'm just flipping my x value. Cosecant is 1 over y, or I'm flipping my y value. Okay, to find the sign of pi halves, I have to think about that ordered pair. And I know that ordered pair is right up here, so that would be 0, 1. And the sign is simply the y value, so my answer is 1. When they're more difficult, like cosecant, I still have to think about that ordered pair. It's 0, 1. And the cosecant is flipping, or taking 1 over the y value, so that's 1 over 1, or still 1. If I'm trying to find, say, the tangent at pi halves, then I think about that point, and I take the y over the x, which is 1 over 0, which is undefined. To find the angle, given a location for sine theta equals root 2 over 2, again, I think about my unit circle. It says between 0 and pi halves, so we know we're only in the first quadrant. And where is root 2 over 2? The only place I have root 2 over 2's is at pi fourths. And of course, the ordered pair is root 2 over 2 and root 2 over 2, so that is my answer. Theta is equal to pi fourths, or 45 degrees. If I do cosecant of theta equals 2 root 3 over 2, I know that we're talking about a root 3 value, so I know that I'm looking for a cosecant is flipping the sine value, so I'm looking for a y value with a root 3 in it. So the place where my y value is going to be, the square root of 3 in it, in the answer, is this one, because my y value is square root of 3 over 2. And when I flip that and rationalize it, this is what I get. So that means my theta is going to be that location, which is pi thirds.